All right, so we're going to look at the classification of living things, and as we're going through the presentation, you want to make sure that you are completing your notes. I also put some color pencils at the lab stations because we will be needing them for some things. Let me get a color that you all can see. You guys got a black Sharpie, black board marker? No, black. Bigger one. All right, like Stefan told us, classification of living things is organizing things, and that's what we're going to look at now, talking about how organisms are organized in order. So, basically, this is Eyeliner's dream date. A gentleman by the name of Carolus Linnaeus, who was born in the 1700s, he came up with this whole organization of living things, which calls classification of living things. He is considered the father of taxonomy. And he's responsible for setting up the classification system to organize all living things into these different categories based on their characteristics. That's the importance, because we can be categorized and classified in this class based on ladies and gentlemen. That's your characteristics. Or we can be classified based on black shirts, blue shirts, red shirts, white shirts. Characteristics, again, do you understand? We can be placed in categories for the entire school as freshmen and sophomore, teachers and students. Do you understand? So he was responsible for doing this for all living things so that we can know what different organisms are different organisms. And the science of classification is actually called taxonomy. Are we good? Okay. So everybody say Biden and Nakaya's dream boyfriend. This is when he's really trying to get ready for the date. All right. When he organized these living things or put them into categories, he organized them from general to specific. And as you can look at here, this is very broad, and it narrows down to being very specific. Do you see that? Okay. Now, what we're going to do in just a moment, we are going to be breaking these things down and getting a better understanding. But when you look at this picture of these things that are on here, what do they all have in common?
Animal.
They're all living things. That's supposed to be a real bear, but I didn't want to scare you. So these are all living things. And Mr. Linnaeus, a.k.a. Eyeliner's dream date, like I said, organized them from general to specific. The very, very, very general area where we can look at organisms and we can say, okay, what's their broadest category or group? This would be kingdom. And I'm going to underline the first letter because we're going to come up with some type of acronym to remember the order of classification so that you remember the order. The next one is phylum with the PH. That's the next group. So basically it says, okay, some things belong in this group. Okay, to narrow it down, we go to this group. To narrow it down even more, we look at the next group so that we can get a specific name for the organism that we're talking about. The next is class. Then we have order. Not odor eyeliner. Then there's family. And then there's something called genus. Not genius like me, but genus. And then there's the species. And I'm going to write this on a slant so I can fit in. You can do the same.
I can fit it across.
Well, then fit it across. Mm-hmm. So again, the reason why it's like this is so that we can get a better identification of the organism that we're talking about, because all living things is very, very broad. And there are so many living things. So, for instance, we all know this to be a what? A lion, right? But we all speak English, and we say lion. But what if you were to go somewhere where lion doesn't mean lion there? How would you be more, and you couldn't say Mufasa because they wouldn't know who that was either. Everybody does not know. But if you were to go to the zoo in another country that did not speak the language that you spoke, and you wanted to know where a certain animal was, say, let's say the lion, just saying lion, they might look at you like, huh? But the classification system is set up so that it has a scientific name that is understood everywhere. It becomes universal. It's a universal language. So what we're going to do with our color pencils, we're going to get a classification for this lion. And we're going to break this classification down. And as we break it down, anything that fits in a specific classification, we are going to, I'm going to re-underline these letters in that color. And we're going to actually circle that organism in the color that we're talking about. It'll make sense in just a moment. All right? So, for the lion, the kingdom, well, actually, I'll leave this. I'll leave this in this color. I want you to write the kingdom of the lion in one specific color. You don't have to use the same color as me, but write it in one specific color. Whatever color you write here, make sure it's the same circle that you circle here. Okay? All right, so are we ready? The lion belongs to the kingdom Animalia, which obviously stands for what?
Animal.
Animal kingdom, which is what you hear on the Lion King. But if we went to another country and we said, I'm looking for the Animalia, what are they going to say? There's a lot of them. So over here, we have Animalia would be, yeah, you need to circle them in the same color. But not the tree. Now I do need that black marker. In your pencil, you cross off what does not belong. So the tree is canceled out. So they would know for sure we're not talking about a plant. Right? So we have to be more specific, and now it's like speaking another language that, oh, no, okay, Animalia, all right. Let me see. The phylum it belongs to is Chordata. And what that means, it's an animal with the spinal cord. Again, use a specific color here, and whatever color you use here, we have to circle over there. So when we say Chordata, then you say, okay, Animalia Chordata. So that means an animal with the spinal cord. So that means we have the bear. And again, it's going to be circled in both colors. What else has a spinal cord? The lion. The cat. The fish. The tiger. But not the worm. Are we so far understanding what I'm saying here? Is there anyone that's lost? Okay, good. All right, so again, you say, okay, I'm looking for an Animalia Chordata, and they're like, okay, well, we got these things, and notice this is not all living things, but it is some of the living things. So then we say, All right, we need to be a little bit more specific. So then you say, okay, the class. What class is the organism that I'm looking for in? The lion is in the Mammalia class. Mammal. And that means any organism that has hair or fur. So what would this be? Okay, you would have the bear. What else? The lion. The cat. The tiger. And not the fish. So we're narrowing it down still, but can we be directed to what we're looking for at this zoo yet? No. So you say, I'm looking for the Animalia, Chordata, Mammalia, or you say, I'm looking for, once you say this, you don't need to keep saying all of these, but you say, okay, I'm looking for the Mammalia. There's like, okay, well, we got a couple of those in here. So you still need to be a little bit more specific. So the order that the lion belongs to is the Carnivora, which means it's a meat eater. So then we look and we say, okay, a bear. Oh, I'm missing an animal here. I knew I was. Sorry. I didn't realize I was missing one here. We need to draw a little deer. This is my rendition of a deer. This is my rendition of a deer. This is Bambi. All right. So Bambi would be colored, circled in orange, green, purple, and red because he fits in the Animalia Chordata, Mammalia, Carnivora. Let's see. The bear, the lion, I'm sorry, the fish is already crossed out. I apologize. The tiger, the house cat, but not the deer. The deer actually eats plants. So then we say, okay, I'm looking for the Carnivora. And they're like, okay, we still have a couple things that we can direct you to. Are we all good? I'll wait for you guys to get caught up. The family that the lion belongs to is the Felidae. But this actually means any organism with retractable claws. So we know that the tiger, the house cat, as long as they haven't been declawed, the lion, but not the bear. They do not have retractable claws. See how this marker retracts this tip? Bears can't take their claws back in, like cats. Cats' claws aren't always out. Bears are. Does that make sense? Okay. So now we say, okay, the Felidae. And they're like, over there. And you look and say, oh, no, that's not just the lion. That's a couple of other things. So then we have another color. The genus that it belongs to is Panthera. And the Panthera, that actually means roaring cat. So when we look, we say, okay, our tiger roars, our lion roars, but our cat says, ah! House cats don't roar. So in the Panthera, we still have two. Have we identified the organism that we're looking for? No. We still have two. Are we all good? Okay. moving to the last one, so that we can get a better understanding or a better look for what we are looking to identify. It's going to do it in black. The species that the lion belongs to is Leo. Leo. And therefore, when we look, we say, that is not a tiger, that's a lion. So then, therefore, a lion would be an Animalia because it is a animal. The chordata because it does have a spinal cord. The Mammalia because it is a with fur or hair. It's in the Carnivora because it eats meat. Philidea because retractable claws. Panthera, roar. And then Leo means lion. So this is what it, Leo, not Leo, I'm saying it in Spanish, means lion. So this is where it would belong. Any questions about this? Okay.
What did you say that the chordata was?
Spinal cord. Chordata. Can I move on? All right. If you notice and you look at these words, you will notice what about them? Are they English words? No. They look like they're in some type of Latin. They are in Latin. And what? Back in these days, scientists actually use Greek and Latin because they are universal languages. I told you this in the very beginning, that our language derives from Greek and Latin, or Latin, because it's universal. So when you go to another country and you say, I'm looking for the Panthera leo, then they know that you're talking directly about the lion, because that is the scientific name for it. The science of naming these things, because we put them in different categories and we use a system, this is called systematics. So taxonomy is the classification or the grouping of characteristics. The science of naming them, naming and grouping the organisms, is systematics. Any questions? All right, then let's look at naming the actual organisms. Because we don't need to say Animalia, chordata, that's just putting into the classification. But actually naming the organisms, for naming the organisms, we use the last two. Stop talking. We use the last two words in each description. These are the ones that are used to name the specific organisms. So using the two names of the organisms, two names, that's called binomial. This means two name, naming, nomenclature. And that actually means two name, naming. Because we use the last two words in their classification to actually name them. The first name is always capitalized and the second name is never capitalized. So looking at your notes, what would be the lion's scientific name? Panthera leo. How is it? Capital P. Leo. Is that understood how that works? Mm-hmm. Any questions for this? Are we all together? Anybody confused? No. Okay, so everything's clear. Can I erase? Okay.
Wait.
Yes.
So why is it just
because that becomes, remember, we're going from general to specific. We start using all that generalization. We have so many things that we can identify with. Okay? But that just helps us to classify organisms in different areas. But good question. Alrighty. So then the classification for humans. What? Oh, thank you. All right, so the classification for humans. Let's go ahead and look at this. For humans, I'm just going to put the letter for our categories. Our broadest category is what? Kingdom. What kingdom do you think we belong to? Animalia. Oh, maybe not. She belongs to the monster kingdom. All right, what's the next category? Category, though, which is phylum. What phylum do you think? Chordata. So we belong to the same kingdom and phylum as a lion, right? This is why, Disha, that we specify it with just the last two, because right now I'm not talking about a human, but I still gonna be talking about a lion, a bear, a tiger. All right. What's our next? Class. What class do you think we are in? Mammalia. What's next? Order. We are primates, which means we are at the head. We are able to think and organize and classify and put things, like make some type of decisions. But so are some other organisms, like monkeys. This is why they say evolution comes this way, because monkeys are the same up to here as well. Okay? Then, what's next? Family. Apes are up to here. This is Hominidae. I just drew a blank. I gotta look it up real quick because I just drew a blank. Oh my God, I can't believe I just... Hominidae is the class of great apes, and what that means is the characteristics of all having like nose, eyes, all in the front of your face, the ears, and things of that nature. So coming down from that classification. I can't believe I just drew a blank with that. All right. And then lastly, or not lastly, what comes next? Genus. Our genus is homo, which means same. We have things that are same within the organisms. And lastly, and who can guess this? This is sapiens. We are Homo sapiens. So what's our scientific name? How do we write it? Capital H. Sapien. Now, what's an acronym that you all can use for KPCOFGS? Because you do need to remember that order. I don't know. King Philip cooked over fire grease, over fire grill Saturday. I don't know. Keep pushing cause our fam gotta survive. That's a good one. Keep pushing cause our fam gotta, how you spell gotta? Gotta survive. True that. All right, that's a good one. So I would write that down because that's definitely something that you are going to want to remember because you do need to remember the order. All right, now notice that we have a kingdom here. But that is a major broad thing. We have Animalia kingdom. But is everything in the animal kingdom? No, there are 6 kingdoms. That when we look at the kingdom, it could be the animal kingdom, but there are 6 major kingdoms. There's multiple classes and orders and families, but there's 6 kingdoms that we're going to look at. And all life on earth can be placed into one of these 6, grow up, groups. These groups are also known as kingdoms. And these groups are categorized based on what, do you think? How do we group things based on what? And the characteristics mean they have to be what? How? Like, I could say, similar. This is similarities. Stop practicing DNA. Again, this is from broadest to specific or general to specific as well. So, what's the jungle? The king of the jungle, or the largest kingdom? What do you think? This is the animal kingdom. Animal kingdom is the largest kingdom. Over here, I'm just going to put some examples. Some examples would be things like bears. Even insects belong in the animal kingdom. And of course, humans. Oh, I forgot I had that. So you can write those things down. I forgot I put pictures there. These would be your multicellular, heterotrophic. What does heterotrophic mean? We eat food for energy. We eat food for energy. That's what heterotrophic means. We eat food for energy. We don't make it. We eat different types of things for our energy. That's heterotrophic. Unlike autotrophs would be what? They make their own food. All right. What do you think our next kingdom is? Plants. This would be things like your fruits, your vegetables, your trees, your flowers. These are autotrophs. They are also multicellular. But they're multicellular autotrophs, which means they make own food. Any questions? Okay. Then our next, we talked about this when we talked about viruses and diseases. Oh, what I mean, erase this. Our next is actually protists. And protists are actually organisms found in a pond. They're microorganisms found in pond water. And you can see the picture of a live protist there under a microscope. All right, are we good so far? All right, who can guess the next? Not yet, but that's a good guess. Fungus. Thought I had a smart board for a second. I got excited. That would be your mushrooms that are outside, your mold on the orange that you left underneath your bed and your mom didn't find out about it yet. That'd also be the mushrooms that you get on your pizza and the fungus that you have on your feet that's probably got you doing all this stumping.
With the fungus.
Athlete's foot is from a fungus. I know. That's why you should wash your feet. Oh, the mushroom, that's a fungus also. It's just an edible one. All right? The next then would be?
Bacteria.
Mike? Bacteria. Well, guess my bacteria didn't come here. This bacteria live almost everywhere. It's on your skin, Nakaya. It's on your table. It's on your clothes, on your shoes. It's in your mouth. It's in your stomach. It's on your hair. It's on your face. It lives everywhere. Good and bad bacteria is everywhere. They're very small microorganisms, obviously. They are single-celled. It's everywhere. You and this obsession. And then lastly, we have something called archaebacteria. It's archaic, basically. And I'm going to write it across here, but you can put it in here, but it's spelled. So it's similar to bacteria with different characteristics. And the different chemical characteristics. And they make up and live in extreme areas, like in swamps. Everyone have this? Are we good? Yes? Okay, lastly then. Good time. Excellent time. The last thing is to be able to identify, come up with this whole characteristics of naming organisms, going from Animalia, Mammalia, Chordata, all of that stuff, putting them into categories. We use something called a dichotomous key. I'm going to show you a short video about the dichotomous key. We're going to finish this, and then there's a little activity at the end that you're going to finish for homework, as well as getting a classification homework sheet. So let's take a look at this video.
Dichomous Key. There's a lot of birds in our world, and if you were asked to identify a bird based on its characteristics, you could probably do it. We could probably name the hummingbird, the owl, the duck, and the penguin based on its features. But if you were asked to name these birds using their scientific name, the task wouldn't be so easy. You wouldn't know the scientific name of these birds just by looking at them. Scientists have figured out a way to make a chart to help you better identify birds based on their characteristics. The chart is called the dichotomous key. Reading a dichotomous key is easy. Take a look at the hummingbird. To use a dichotomous key, start at number 1. At number 1, it's asking us to observe the feet of the bird. A hummingbird does not have webbed feet, so we'll go to step 3. Step 3 has us examine the bird's tufts. Our bird does not have tufts. We just figured out the scientific name. Let's try the dichotomous key again with a different bird. This time we have the penguin. Start at number 1. Our bird has webbed feet, so we're going to have to go to step 2. Step 2 has us count the number of toes. A penguin has 4 toes. We just figured out the scientific name of the penguin. Using the same chart, we can figure out the scientific name of the duck.
All right, so we're going to stop there so we can finish this up. So a dichotomous key is a tool that allows the user to determine what? The identity of items in natural world? Hello? The identity? Because we need to identify it. So it's a tool to help us determine the identity of items in the natural world. Yeah, we can say duck, but does that help us? No. This key helps us to break this down and say, okay, if your animal has fur, if it has fur and it has a spinal cord, then it's chordate. If it has a spinal cord, then it's chordata. If it has fur, then it's in the mammalia. So these key consist of a series of choices that lead the user to the correct what? The correct what? What was the end result? Scientific name. We're going to do one of the examples of the activities at the end of your notes, and then you have homework to finish this activity in addition to your classification homework. This part is very simple. So we're going to look carefully. This is how Dichomous Key works. Looking at these aliens, so this would be probably Nikaya. We're going to look carefully at these pictures, and we're going to use the Dichomous Key to find the scientific name of each one. All right. So basically, you look at number 1. So we look here and we say, okay, a mouth open. All right. So we got this one and this one. Oh, I'm sorry. I apologize. We're going to start here. And we say, okay, at 1, A, it's a mouth open. So we know that it's this one. So we're going to go to number 2 because it has its mouth open, correct? So we go to number 2. It says arms or no arms. It does not have arms. So we know that the name is Alienus quadrigallicus. What's wrong, Shania? We don't start up here. We actually start at the actual aliens. So we look at them. We go to number 1, and it says mouth open or mouth not open. Its mouth is open. So it tells us to go to number 2. We go to number 2. We say arms or no arms. No arms. There's the name. Let's do the second one really quickly. Back to 1. Mouth open, mouth not open. Not open, so we go where?
4.
Number 4.
What mouth not open?
This one.
The second one. Oh,
I thought I was on the crows.
No, we have to go this way. And then you say arms or no arms. I'm sorry, horns or no horns?
no.
No horns. So we go to number 5. No legs or legs? Legs. So this name is Alienus fuzzicus. Okay? This one. I'm over here. All right. So again, you need to finish this for your homework. And don't forget to work on your classification homework. You all can start packing up the homework I just passed out to you.
What's that yellow one? I will find out the name. That's going to be used now. Miss Lee